Hello, my name is Yogendra and I'm a maths teacher at askIITians. Okay, so we are going to do today polynomials, first lecture, okay, on polynomials. And and as you can see, okay, there is like good weightage of this chapter in your final exam. It is going to be, it comes for 9 to 10 marks, and it is really important for remaining of the chapters also, because concepts from this chapter will be used in other chapters also. And the same chapter, polynomials, is there same by the same name. It is there in 10th grade also, so that way also it is really important to understand the concepts related to polynomials. So we are going to start it, okay, and you need to pay attention to what we are going to understand here. So every single point is going to be very important here, so pay attention to every point here which I am going to mention. So we are going to see standard form of polynomials. What is the degree of polynomial? Polynomials in one variable, types of polynomials, and value including zero of a polynomial. Right? We need to see the what is the value of polynomials. Right? So let's start with the standard form of the polynomial. So what is basically standard form of the polynomial? If we write anything like this, a x power n, a naught x power n plus a1 x power 1 n minus 1 plus a2 x power n minus 2. You can see I'm writing decreasing. This x is what? Here it is a variable. X is a variable. X is a variable. Please wait a minute. Okay, I'm going to explain it. Okay. X is a variable, and a naught, a1, a2, and so on are what? Constants, coefficients, or constant. So these are the coefficients. So here polynomial is what? How do we define it? Basically a n, and yes, x power is going to be 0. So this is what it is. Now I can name it as p of x, polynomial. What is the meaning of this p of x here? Polynomial in variable x. So if you need to define, okay, it is like by the word name polynomial. So poly means poly stands for many, and nomials means what we say? Num Terms. Okay, like terms. Okay, this is like first term, second term, third term, fourth term, right? Like that, plus or minus differentiated term. So there are many terms here which we are going to study, and variable is like one only. So it is one variable, many terms, right? So this is what poly means, many terms. Now it can be like three terms here, right? This is what here, x square plus x. These are the examples of a polynomials in standard form. So these are polynomials. It is 2-degree polynomial. Now I'm going to define what is degree also, but before that, okay, you can see these all are polynomials here we have, right? All these, like this is one of the polynomial, this is another polynomial, this is another though variable is different here. Here variable is y, here variable, okay, it should be y here plus 7. Yeah, and it is x variable here also. You have to remember this n, the exponents has to be whole numbers. Okay, exponents in a polynomial are supposed to be whole numbers. If it is not whole number, means it is negative number or fractional number, like that. So then we cannot call it as a polynomial. Okay, exponents has to be what? Whole number. So this point you need to remember. Okay, these are the examples. Okay, by the way, yes, here you can see here known examples of polynomial in standard form. Okay, yes, okay, what is it actually here? It is like, it's not written in the standard form. Standard form is what? When we are maintaining the order of exponents in the decreasing order. Here 22, then 20, then 1 here. Here it is what? Increasing. So this is not in standard form, but we can bring it in the standard form, right? So this is what it is there. Okay, you can remember this also, that 7y means 7 power. Y power is what? 1. You have to remember that. Okay. Like this, we can write the standard form. Standard form will be what? X square plus x plus 3. Like this is what decreasing order we need to maintain. We can bring this also in the standard form. Okay, I think it should be y here. Yes, because 7, if 7 only there, then we can add it. Okay, so what is the need to write separately, right? So that's what it is. Okay, by the way, this is standard form. There is nothing wrong with this. There's standard form, so by mistake it is put up here, but I hope you can make the difference. Okay, this is what standard form means, more decreasing. You can see in the this example, x power n, x power n minus 1, x power n minus 2, and x power, like that it will keep on decreasing, right? And the coefficient of x is what here, these are going to be some numbers. Those numbers could be of any format. Don't misunderstand that those numbers are also has to be some whole numbers. They can be any real number. It could be root 2, it could be 0.001, it could be like any coefficient, it doesn't matter. But the exponents of variable has to be whole numbers. That's what the polynomial form. So any algebraic expression, if we need to define it, okay, any algebraic expression which is written in this form, okay, a x power this, like that, is called as polynomial. And to name it, okay, to give the name of it, okay, we say p of x. So p and then bracket x, right? I hope you are able to understand this. Yes. So yeah, we can continue then further. Yes, let's continue. So next we have degree. What is the degree of polynomial? It is very simple. The highest exponent. The degree of a polynomial is the highest exponent we have in the expression, right? Like here, 4x cube minus 9x square plus 6x. So what is the highest exponent? Degree is what? 3 here, because highest exponent is what? 3 here. Leading, and by the way, this 4 is called as leading coefficient. The coefficient of leading coefficient is what? The coefficient of highest uh, highest exponent variable term. Highest exponent term, we can say like that. So degree of a polynomial is the highest of the degree of monomials individual terms with non-zero coefficient. Yes, it has to be non-zero. It cannot be zero, because if it is zero, then it will be like the whole term becomes zero. So then this will not count as degree. Are you getting it? So this is what it is important. So degree is what here? 3. Now, for example, if I say, I can take many examples here. Like if I write polynomial is x plus 1. This is what my polynomial p of x, I can give name. So degree is what here? Degree, you can think, okay, what it is going to be? 1. Now another example, I can take x. Now it is x plus x square plus 1. What is the degree? It is 2. Though it is not written in the standard form, because first it should be highest exponent term, then we should write decreasing order of exponents, okay, like that. So degree is what? 2. You need to understand, if it is not given in the standard form, it's not a problem, but we need to identify that degree is what? Highest exponent. Now if I write something like this, p of x is equals to x plus 1 by x. Degree is not there. Why? Because this is not polynomial format, and degree is defined for a polynomial. So you will not say that degree is 1 or degree is minus 1. Degree is it's not a polynomial, so there is no degree. It's not a polynomial, so how can we define the degree? Degree is defined for a polynomial only. Now they can ask how many terms are there. So how many terms? Number of terms are 2. Number of terms here are 2. Number of terms are 2, and here also, here number of terms are 3, right? This is the column I'm giving for number of terms. You can understand here how many terms are there? 3, right? X degree is also 3. So this is what, okay, this is what it is going to be. Now they ask, okay, what is the, if there is a constant polynomial, p of x is equals to 5. There is a constant polynomial. What is the degree of constant polynomial? It is what here? Okay, what is there here actually? Do we have 1 here? Yes, for every number 1 is present there. So 1 into x power 0, and any variable to the power 0 is what? Always 1. Any number to the power 0 is what? 1. So that's why what we can say, degree is what? 0. So there is a very important point here, we can say. Important point is what? Degree of a constant polynomial is 0. Degree of a constant polynomial is 0. Degree of a constant polynomial is 0, because for any constant, it could be anything, right? 1000, right? Degree is what? 0. Okay. So there are more examples, okay, we will take, and more things we will understand. Okay, there is one more point you can write down. What is 0 polynomial? If I write just like this, p of x is equals to 0. Before coming to these points, I want to explain this. Okay, let's note down this. P of x is what? This is equals to 0. This is called as 0 polynomial. Don't you need to remember, it is 0 polynomial. The name of this polynomial is what? 0 polynomial. Something like 0 of a polynomial we are going to see later on, but it is what as of now? 0 polynomial. Now what is the degree of 0 polynomial? Its degree, my bad, its degree is not defined. You have to remember, its degree is not defined. Now why it is not defined? Because what happens, 0 into x power 5 is also 0. 0 into x power 3 is also 0. So we are not sure, okay, what should we write? Okay, 0 into this, 0 polynomial can be written x into anything, so that's why it is not defined, right? So you need to remember, right? Because of this reason, it is not defined. Okay, by the way, polynomial in one variables, I hope you got the idea that polynomials in one variable means there is only a single variable in the polynomial, right? Like so far we have seen one variable, but it might be mixed variables also. It could be like x and y also there in present in the one variable. Okay, like I can say like there is some expression x square plus y square plus xy. This is what polynomial, but there are two variables involved. This expression is also polynomial, right? But two variables are there in one only, right? So that's why this is like two variables. But what we are going to do, we are going to deal most of the time with one variable only. So that's why, that is what you need to make sure. Polynomials in one variable are what? These all you can see, right? These all are polynomials in one variables, right? They're telling what are the coefficients. You can understand. This is just a matter of convention. We can only choose any other better, like, so we generally represent. Okay, these all points. Okay, yes, what are they trying to say? That we can have the variable as y, we can have the variable as z, we can have the variable as t, right? And most like in physics you might be using it, okay, that velocity time relation, right? Suppose 2t plus 1, right, like that. 2t plus 1. So according to the time, velocity changing or speed is changing, right? So that's what, like, it is depending on the time, right? So velocity time graph. So t is what variable here, right? Time is the variable. So it could be anything. So that's how it is. Okay, that's how, this is what polynomial and time variable. Okay, like variable is, it could be anything. So it's our just convention, right? So I hope you got the idea. We'll discuss about Degree, you understand. Now, classifications of polynomials. There are linear polynomials, quadratic, and cubic. Now, what are linear polynomials? When degree is 1, right? Simple, linear. Why do we call them linear? Example of linear. P of x is equals to like 2x plus 1. Degree is 1. So this polynomial is what? It is linear. Linear polynomial, degree is 1. So like every polynomial we can graph on our graph paper. Okay, so what happens, okay, why the name we gave, okay, here you can say like linear here, because its graph is going to be always a line. Y is equals to, for that p of x we need to take as y, and 2x plus 1, so we can graph it. Okay, and it is going to give us some graph, okay, like this. Yes, so this is what, okay, straight line graph, by the way. So as it is line, so linear, right? So degrees has to be 1 for a linear. Quadratic, 2 variable, 2 degree, sorry, degree is what, 2. Quadratic example, any polynomial of this form, x square plus 2x plus 3. This is what, degree 2 polynomial, right? Degree is what, 2. Right, now why, and cubic is degree 3, right? Now why we are naming them? Because we are going to deal most of the time linear, quadratic, or cubic. These are like most commonly used polynomials in our study further. So that's why this is what we need to remember. We need to give them some name, right? So that, because we are going to deal with them, okay, most of the time, right? So it is like that. Okay, so we can understand graphing also, okay, later on, but let's talk about more about the polynomials. Okay, if you want the example, you can write down p of x is equals to x cube. By the way, if you want, you can write 5x cube plus just decreasing power, so x also I can write down. This word just example, because degree has to be 3, that's all. Cubic polynomial. So I believe it is all easy, right? We can graph each one of them. Now, what is the idea of graphing? How do we get the graph? We will see that later on. Okay, if it is not there, I'll show you. But graphing is also one of the topic we will be covering, right? So let's move on to next. Okay, now for each of the following, write down its degree. So I believe it is very easy. What is the degree here? Degree is what? It is like 3z plus 1, it should be written, but it is not a problem, right? Degree is what? Variable degree is what? 1. So that's why degree is what? 1 here. Now what is the degree here? Degree is 2. Now what is the degree here? Okay, you will not look at the first term only. You need to see further. What is the highest, right? What is the highest exponent? So degree is what? 5 here. Yes. Standard form also we can write, okay, if you want to write, but I hope it is easy, right? You can understand. So you can need to remember, degree of 0 polynomial is undefined. Degree of constant polynomial is what? 0. This is what, these are like important questions. Okay, they ask 1 mark question, so you should be able to answer that. Okay, now what are monomials? Okay, monocycle, right? Based on the number of terms, we define monomials. Monomials is what? Algebraic expression which has only one term. Okay, one non-zero okay, by the way, yeah, what do they mean by this? Okay, see, if I have a polynomial p of x, which is what p of x is written as x square, or let's say 3x square. This is what monomial, because one term is there. Now they're saying one non-zero term. What do they mean? If I write here 0 into x, does it change it at all? No. So others are like 0 times something I can add. There is no problem. 0 times x raised to 5 also I can add. There is no problem. But it doesn't change the degree and all. Okay, degree is what? 2 here. And there is one term. These are all like 0 times. So they will all become 0. So non-zero terms are what? 1 only. And which is what? Are deciding factor, okay, whether it is monomial or binomial or trinomial, like that, right? A is in monomial in one variable a, right? Yes, 2a by x. By the way, this is also, if I write something like 2x power 3 into y divided by x raised to 10 or something like that, okay, like x raised to anything, right? This one, this is also a monomial. Division or multiplication doesn't differentiate the terms, only plus and minus differentiate the terms. Monomial it is, right? So I hope it is easy, it's not that difficult at all. Binomial when it has two terms, right? Basic, right? Okay, when it has two terms. Binomial is algebraic expression that has two non-zero terms. Example of a binomial is what? M plus n. There are two terms. 11p minus q square is what? Binomial. Okay, more useful example let me give you here. P of x is equals to 2x plus 1. What is it? Monomial. Sorry, binomial, my bad. Binomial. Why? Because there are two terms, first term, second term. Yes. Another example, p of x is equals to x square plus 2x. Binomial, right? Again binomial, right? Two terms it has to be, right? They have taken two variables, but I'm taking one variable because you are going to deal more with the one variable things, right? Trinomial, three terms, right? Tricycle. Nice. Okay, trinomial has three terms, right? Three non-zero term. So you can see easily, right? I hope it is clear. Perfect. Very easy to understand. Three terms are there. Degree doesn't matter, by the way, to decide like how many terms are there. It degree doesn't matter. Degree could be anything, but to decide whether it is monomial, binomial, or trinomial, we need to see the number of terms only, right? Which of the following is a binomial? So which is binomial? This one is a binomial. Yes, this is what binomial. Here, terms, number of terms are what? 3 here. Here, monomial. This is monomial. By the way, this is also binomial. This is binomial. This is binomial because it is 8a plus a, right? So that is what binomial. Wait, wait. What is the change here? 8a plus a. What it will become? Okay. It is what? 8a square. So it's, my bad. Is it correct? No. This is not binomial. Why? Because it can be added. Okay. So if like terms are there, we can add it. Okay. Suppose we have 8a. Okay, 8a only. So a plus a plus a plus a. Okay, like this, if I write 8 times, so does it become 8 terms here? No, it is like just one term. So right, it is monomial here. This is monomial, but binomial is what? This only, right? This answer is not correct. A. So that's why we need to look at the all the options. I thought, okay, this is what it is there, like that. Okay, but it can be added, right? 8a plus. I'm so sorry. Okay, again, there is a mistake here. Let me erase it. Think. Let me correct it. Yes. 8a plus a. It is what? 9a. And this is what? Monomial, right? A option is what? Monomial. B option, which is what? 7a square plus 8b plus 9c. Trinomial. C option, which is what? 3a into 4b into 2c. Monomial. But this one clearly has two terms which cannot be added or like that, right? Because they are unlike terms. So that's why this is what binomial. I hope you understand this. Yes, so this is what it is. Types of polynomials you have seen. This is a brief about the polynomials, but we are going to see more things, which is what really important thing. Next topic is what very, very important. I hope you got the idea, right? Okay. So this is really important. What we are going to see next. value of a polynomial. How do we find out the value of a polynomial? So value of a polynomial p of a at x equals to a is defined as p of a, right? You need to understand this is very, very important point here. How do we say the value of the polynomial? So suppose some polynomial is there, p of x, which is what? X square plus x plus 1, suppose, right? Like this is there. So if I substitute x equals to 1, so what we get? P of 1 is equals to 1 square plus 1 plus 1, which is what? 3. So what is P of 1? We are getting as 3. So what we say here, value of this polynomial, value of P of x at x equals to 1 is 3. Are you getting me? This is what very, very important. You need to make understanding out of it. Okay, that p of x is what? X square plus 1, x plus 1, right? And then at x equals to 1, we are getting p of 1 as 3. So p of 1 is what? 3. Value of the polynomial at x equals to 1 is what? 3. So this is what value of polynomial is what? 3 when x is 1. Like that, it can have thousands of values, because we can replace x by any number and we can get many values here, like that. So a polynomial has thousands of values like this. So those values, okay, so roughly if we say x equals to a could be anything now. So p of a is called as value of polynomial. This is called as p of a, will be called as value of polynomial. P of a will be some value, right? So that value is called as value of the polynomial. So p of 1 is what? 3. So this 3 is the value of the polynomial, or p of a is called as value of the polynomial. Exactly, right? Do you understand? Now here f of x is equals to x cube plus 3x minus 1. Now suppose x equals to 2, we are substituting. So what is the value we are getting? 4, then 6 minus 1. So it is what? 9. So value of this function, polynomial, actually f we use for function, but it is what? Again polynomial of 3 degree. So this is what? Polynomial of degree 2, which is degree 3, which is having value how much? Okay, it is 2, or they have calculated according to 2. So let me change it here, right? Okay, this is what? 2. So 2 square plus 3, this one we are getting 9. So value of polynomial at x equals to 2 is what? 9. This is what we need to understand here. Value of the polynomial is what? 9. Now what is 0 of the polynomial? So for some numbers, for few numbers, we get the value of the polynomial 0, right? Value of the polynomial becomes 0. So that time, that particular number is called as 0 of that polynomial. Are you getting me? That at that point of time, okay, let me take one example, simple example here. If I say p of x is equals to x minus 5, right? P of 2, if I find out, what I'm getting? 2 minus 5 is equals to 0, right? Now if I put oh, sorry, I'm thinking, what I thought, okay, that is what I've written. Okay, the like I was going to write 0 next, but I wrote here. Okay, let me change it. What it will be? Minus 3. So is x equals to 2? What I replaced x equals to 2, right? In this polynomial. So x equals to 2 is not giving 0. But if I replace x equals to 5, so p of 5 is becoming what? 5 minus 5, which is what? 0. So x equals to 5 is 0 of p of x, right? X equals to 5 is the 0 of this polynomial, right? Same way here, if you see this example, if you look at this example, x equals to 2, x equals to 2 is making it 0. So x equals to 2 is the 0 of this polynomial. That's all, as simple as it is, right? This is what we need to understand. This is, and after this we are going to see factor theorem, remainder theorem in next lecture. So that is all depends on this, right? This concept is what you need to remember, right? So this is what we need to understand, right? Now see these questions we can practice. Find the 0 of following polynomials. So what are the zeros here? If I see, okay, One method is what? Okay, randomly I can do x equals to, I try to put 0, then okay, I'm not getting 0. Also could be a 0 of 0 of the polynomial, right? 0 also could be 0 of the polynomial, whichever value makes it 0, right? So if I put 0, I'm getting f of 0 is equals to 1, right? That is not giving me 0. Okay, x equals to, if I put -2 -1, right? No, it's not giving. Which is what? -3, right? So how to do that? Okay, let's put it. Okay, what is my f of x? What is the easier way to calculate this? By trial and error method, we sometime like we can't get it okay like that. Okay, we can think about it later, but as of now, like make it equal to 0. So 2x is equals to 1 goes to that side -1. So x is equals to -half. This is what 0 of the polynomial. This is what 0 of this polynomial, right? You can try putting this, okay, -half. If you put it will generate -1, and -1 plus 1 becomes 0. So that's why that is what 0 of the polynomial. Same thing you can do here also, right? I believe it makes sense. This is what 0 of the polynomial. So this is what we have, right? This is what we understand, right? We can always do these practice questions, right? So this is what 0 of the polynomial, right? The value of the polynomial could be anything. That is also important for us. But there are few x variable values. I'm not saying, there are two different things you need to understand: value of the polynomial and x values. X values are like input, and value of the polynomial is like output. After inputting, by the way, yes, let me tell you, like, what is f of x is called as, depending on x values we get f of x, right? So x is what? Independent variable, and f of x is called as depending variable. So it depends on the x values, right? So when I input something, I'll get the output. So x values we can choose freely, any value we can input, but we are looking for those values which can make that function value to 0, that which can make that function 0. So those are called as zeros of that polynomial. Means x equals to something will be called as 0 of the polynomial. If you want to define it, because definition is not written, so I can give you that. Okay, let us write down the definition here. What is 0 of polynomial? Value of polynomial, value of variable, I'm so sorry, value of variable x, or variable could be anything, value of variable which makes polynomial value 0 is called as 0 of polynomial, right? I can write down in another way also. If x is equals to a, such that p of a is equals to 0, x is equals to a such that p of a is equals to 0, then x equals to a is that value of x which can make value p of a as 0, value of the polynomial as 0, is then that value is called as 0 of given polynomial. Now how many zeros could be there for a variable, sorry, for a polynomial? Okay, that is different story, we will see that. Okay, but you need to remember it can have more than one. Okay, depending on the polynomial, we can have more than one zeros also. It is not like just one. Okay, right? So yeah, this is all. Okay, we have seen this, right? We got the answers. Okay, let's see these questions, practice questions we can do, because in maths without practice, okay, nothing is like easy. Okay, in maths. Okay, so first question: if f of x is equals to x square minus 4x plus 3, find the values of f of 1, f of minus 1, f of 2, f of 3. Also find the zeros of this polynomial. Okay, very good. Let's do this question. Okay, so first question solution I'm writing here. So f of x is equals to x square. You should always try it first yourself. Okay, you can pause at the questions only without looking at the solution. You should do it. Okay, I would suggest that only first you to do. Okay, you should not look at the directly solution, because I hope it is easy and you have understood everything, right? I explained every single step clearly, so just do it yourself, right? Now to get f of 1, I need to find out I need to replace x as 1. So f of 1 is going to be 1 square minus 4 into 1 plus 3. So what are we getting? By the way, 0 we are getting. Very good. 4 and minus 4. Yes, it is 0. Now x equals to minus 1. So can I say here only, because next part is what? 0 of the polynomial. So this is what? 0 of polynomial. This is one of the 0. Minus 1, let's see. Minus 1 square minus 4 into minus 1 plus 3. So we are getting here 4, 7 and 8, right? 8 we are getting. Now x equals to 2. So f of 2 is what? 2 square minus 4 into 2 plus 3. So what are we getting? 4 plus 3, 7 and minus 8. So we are getting minus 1, right? You can get x equals to 3 also. F of 3 is going to be what? 3 square minus 4 into 3 plus 3, right? So 9, 12. Yes, that is also 0. You can see, right? So this is another 0. So what are the zeros of this polynomial? Zeros are 1 and 3. Okay, now you can say, sir, you luckily got here, but if we don't know this, like how should we do it? Okay, no problem. That method also I'm going to tell you. You can factorize this splitting middle term method. We are going to see this later on also, but I'm just telling you, like, this is called as splitting middle term method. X square minus 3x minus x. We just break down this 4x as middle term ko I can split like this, 3x and minus x plus 3. So what I can write down now? X common, x minus 3 minus 1 common, x minus 3. So we are getting x minus 1 and x minus 3. Now equate to 0. So we are getting x equals to 1 and 3. That's how we got the zeros. So this is also zeros we get like this. Yes. Now degrees. Next question. I hope it is clear, right? You need to always do more questions, okay, to understand it this clearly. Degree is what here? 2. What is the degree here? Degree is what here? 2. What is the degree here? What is the degree here? It is not, by the way, it is not the one variable polynomial. It is like two variables are there, right? So degree is what? Okay, now what should we say here? Degree should be what? Where 1 degree here for this a and 1 degree for this. So ideally we should call it 2 degree, right? Because two variables are there. So this generally defined in the question that what is the degree here given. So it is what we need to take here 2, right? Okay, I think they are doing some mistake in the answers. Okay, like we got here degree 2. This is fine. But in the first part answer, right? Clearly they're missing it out. Okay, I think, right. No. It's fine. It's fine. 0. They're writing 0, 0, 8, minus 1, and 0. Right? We got the answers. Fine. So you need to watch the next lecture also, because polynomial is not just this chapter. We need to do next lecture on this chapter, and that is going to be really important, because in that we are going to discuss the core of this chapter, which is what remainder theorem, factor theorem, and uses of those concepts are there till your 12th grade, right? You need to remember those two topics very, very clearly. Okay, so watch the next class recording, and next lecture recording you need to watch, and you need to make sure that you're understanding this chapter properly, right? Okay, thank you very much for your time.